In the infinite expanse of the cosmos where darkness reigns, there are realms where light is born. Nebulae, vast, shimmering clouds of gas and dust. The universe's cradles where stars take their first breath. These are the cosmic nurseries, where the raw materials of creation weave tapestries of light across the void. Imagine a place so immense it spans hundreds of light years, yet so delicate its tendrils sway in the silent winds of space. Welcome to a journey through the heart of creation, where the seeds of galaxies are sown. Picture a nebula's glowing heart, a symphony of colors, vivid pinks, deep purples, and electric blues, swirling in a dance older than time. These clouds, born from the ashes of ancient stars, are sculpted by stellar winds and radiation, their shapes ever-changing, like dreams cast across the sky. Hydrogen and helium dominate, but traces of heavier elements, carbon, oxygen, forged in stellar furnaces, sparkle like cosmic jewels. Each nebula is a canvas, painted by the universe's unseen hand. Deep within this nebula, gravity begins its work. A cloud of gas, denser than its surroundings, feels the pull of its own mass. It collapses, slowly at first, then faster, heating as it contracts. Particles collide, sparking friction, igniting the first faint glow of a protostar. This is the birth of a star, a moment of cosmic alchemy where chaos becomes light. The nebula trembles, its gases rippling as the newborn star's energy pulses outward. As the protostar matures, it finds its rhythm. Its core reaches millions of degrees, triggering nuclear fusion, hydrogen atoms merging into helium, releasing torrents of energy. Light floods the nebula, illuminating its intricate folds, casting shadows across vast distances. This star, one of thousands in the nebula, is a beacon, a promise of worlds yet to form. Its glow reveals the nebula's secrets, filaments of gas, dark lanes of dust, and clusters of sibling stars awakening in unison. This is a stellar nursery, a place of relentless creation. Thousands of stars emerge, each with its own destiny. Some will burn steadily for billions of years, anchors of future solar systems. Others, more massive, will flare brightly and die young, their lives measured in mere millions of years. Their light paints the nebula in hues of hope and chaos, a cosmic masterpiece that shifts with every passing eon. Around these young stars, the nebula's remnants swirl. Dust and gas caught in the star's gravitational embrace form a spinning disk, a protoplanetary disk, the cradle of planets. Particles collide, sticking together, growing from grains to pebbles, from pebbles to planetesimals. Over millions of years, these seeds of worlds coalesce, forming rocky planets, gas giants, or icy moons. The nebula, once a chaotic cloud, now sculpts order from its own substance. In this nebula, every star and planet tells a story. Some worlds will bake under their star's fierce heat, their surfaces molten and scarred. Others will freeze in the outer reaches, their atmospheres locked in ice. A few, perhaps, will find the delicate balance needed for life, their skies shimmering with the promise of consciousness. From chaos comes order, from dust comes the potential for life. Emission nebulae, the glowing beacons. Across the cosmos, some nebulae blaze with radiant energy, their vibrant hues piercing the darkness. These are emission nebulae, cosmic beacons illuminated by the fierce light of young, massive stars. Their glow is a testament to the universe's power, a spectacle of ionized gases painting the void with brilliance. Let's dive into their radiant hearts. Emission nebulae are born where massive stars ignite within clouds of hydrogen. These stars, giants among their kind, emit torrents of ultraviolet light, stripping electrons from hydrogen atoms and setting the gas aglow. The result is a luminous display: reds and pinks from ionized hydrogen, blues and greens from oxygen and nitrogen. Picture the Orion Nebula, a glowing cauldron just 1,344 light-years from Earth, its heart pulsing with the light of newborn stars. Within these nebulae, the interplay of light and matter creates intricate structures. Filaments of glowing gas twist like cosmic rivers, while dark knots of dust cast shadows across the nebula's face. The radiation from young stars sculpts the gas, carving out cavities and pillars, like the iconic pillars of creation in the Eagle Nebula, where gas and dust stand defiant against the erosive winds of stellar radiation. The chemistry of emission nebulae is a dance of energy. Hydrogen, the most abundant element, glows red as its electrons recombine, emitting photons in precise wavelengths. Oxygen adds a greenish hue, nitrogen a faint blue, each element contributing to the nebula's palette. These colors are not just beautiful, they're a cosmic code, revealing the nebula's composition and the intensity of its stellar engines. Young stars within emission nebulae are often massive, born from dense clumps of gas that collapse under gravity's pull. These stars, sometimes 20 times the sun's mass, burn fiercely, their lives short but brilliant. Their ultraviolet radiation ionizes vast regions, creating glowing bubbles that expand outward, reshaping the nebula over millions of years. Yet, within this brilliance lies creation. The same stellar winds that sculpt the nebula trigger new star formation. Shockwaves compress gas clouds, sparking collapses that birth new protostars. The nebula becomes a cycle of destruction and renewal, its glowing clouds both a graveyard for old gas and a nursery for new stars. To gaze upon an emission nebula is to witness raw energy made visible. Its light, born from the fury of massive stars, reaches across light years to stir our imagination. These nebulae are the universe's fireworks, fleeting yet eternal, inviting us to ponder the forces that shape the cosmos. Reflection nebulae, mirrors of starlight. In the vast darkness of space, some nebulae glow softly, not with their own fire, but with the borrowed light of nearby stars. These are reflection nebulae, cosmic mirrors that scatter starlight into delicate hues of blue and silver. Their serene beauty offers a quieter vision of the universe's grandeur. Let's explore these shimmering clouds. Reflection nebulae are composed of fine dust grains, tiny particles of carbon, silicates, and ice that scatter the light of nearby stars. Unlike emission nebulae, they lack the intense radiation needed to ionize gas, so their glow is gentle, like moonlight on a cosmic scale. The Pleiades star cluster, wreathed in a soft blue haze, is a perfect example, its star's light reflected by clouds of dust just 440 light-years away. The dust in these nebulae is a marvel of physics. Each grain, smaller than a speck of smoke, scatters shorter wavelengths of light, blue and violet, more effectively than red, giving reflection nebulae their characteristic azure glow. This scattering, known as Rayleigh scattering, is the same process that paints Earth's skies blue, a cosmic echo linking our world to the stars. These nebulae are often found near young stars, their dust clouds illuminated by the steady radiance of their neighbors. The stars themselves may be modest, like those in the Pleiades, or brighter giants casting light across vast distances. The nebula's shape reflects the interplay of starlight and dust, with wisps and veils forming intricate patterns against the dark void. Reflection nebulae are not just passive mirrors. Their dust grains are seeds of future worlds, the raw material for planets forming in nearby stellar disks. Over millions of years, these grains may coalesce, drawn by gravity into planetesimals, then planets, carrying the nebula's legacy into new systems. Yet, these nebulae are transient. Stellar winds and radiation gradually disperse their dust, fading their glow. What remains may drift into the interstellar medium, joining new clouds to begin the cycle anew. Their fleeting beauty reminds us of the universe's impermanence, a moment of light frozen in time. To stand within a reflection nebula's glow is to feel the universe's quiet elegance. These clouds, illuminated by the stars they cradle, invite us to pause and reflect on the delicate balance of light and matter. Dark nebulae, the cosmic shadows. Not all nebulae shine. Some lurk in darkness. Their dense clouds of dust and gas blotting out the light of stars behind them. These are dark nebulae, the universe's silent sentinels, hiding the cosmos' secrets within their shadowy embrace. Let's peer into their mysterious depths. Dark nebulae are dense clouds of interstellar dust and gas, so thick they absorb and block the light of stars and galaxies beyond. The Horsehead Nebula, a stark silhouette against the glowing backdrop of Orion, is a striking example. Its equine shape carved by the interplay of dust and stellar radiation. These nebulae appear as voids in the starry sky, yet they are anything but empty. Within a dark nebula, the density is staggering, millions of particles per cubic centimeter compared to the sparse interstellar medium. This density shields the nebula's interior from external radiation, creating cold, quiet regions where temperatures drop to just a few degrees above absolute zero. Here, molecules like carbon monoxide and water ice form, cloaking the nebula in a frosty veil. These dark clouds are cradles of creation, despite their ominous appearance. Their density makes them prime sites for star formation. Gravity pulls gas and dust inward, forming dense cores that collapse into protostars. The Bok globules, small, isolated dark nebulae, are perfect examples, each a potential nursery for a single star or small cluster. Dark nebulae are sculpted by their surroundings. Stellar winds from nearby stars erode their edges, creating dramatic shapes like the pillars of the Carina Nebula. Radiation from massive stars nibbles away at their boundaries, illuminating their rims while plunging their cores into deeper shadow. This dance of light and darkness shapes their eerie beauty. Though they block starlight, dark nebulae are not lifeless. Their interiors hum with chemistry, as molecules form and react in the cold, shielded environment. Some scientists speculate that complex organic molecules, the building blocks of life, may arise here, waiting to be incorporated into new stars and planets. To encounter a dark nebula is to face the universe's mystery. These clouds, opaque and silent, remind us that not all creation is visible. They hide the future, stars, planets, perhaps life, within their shadows, waiting for gravity to unveil their secrets. Planetary nebulae, the stellar farewell. When stars like our sun reach the end of their lives, they do not fade quietly. They cast off their outer layers, creating glowing shells of gas called planetary nebulae. These ethereal clouds, shimmering with vibrant colors, are a star's final gift to the cosmos. Let's witness their fleeting beauty. Planetary nebulae form when a star, having exhausted its hydrogen fuel, swells into a red giant. Its outer layers, no longer bound by gravity, are expelled in waves, forming a glowing shell around the star's hot core. The Ring Nebula, a glowing donut of gas 2,300 light-years away, is a classic example, its symmetry a testament to the star's graceful exit. The core of the star, now a white dwarf, blazes with ultraviolet light, ionizing the surrounding gas. This causes the nebula to glow, green from oxygen, red from nitrogen, and blue from helium. The interplay of these colors creates intricate patterns, rings, bubbles, and hourglass shapes, each unique to the star's history and the forces shaping its ejected gases. Planetary nebulae are short-lived by cosmic standards, lasting only tens of thousands of years before their gases disperse into the interstellar medium. During this time, they reveal the star's inner workings. The white dwarf's intense radiation and fast-moving winds sculpt the nebula, creating jets, knots, and wisps that defy simple explanation. These nebulae are cosmic recyclers. The gases they release, enriched with carbon, nitrogen, and oxygen, are scattered into space, seeding future nebulae and star systems. Some of these elements may one day form planets, perhaps even worlds capable of supporting life. The nebula's beauty is thus a bridge between stellar death and new beginnings. Each planetary nebula is a portrait of its star's final moments. The Cat's Eye Nebula, with its concentric shells and jets, tells of a star's complex evolution. The Helix Nebula, resembling a cosmic eye, gazes back at us, its gases spiraling outward in a delicate dance. These shapes challenge our understanding, hinting at unseen forces at work. To behold a planetary nebula is to witness a star's legacy. Its glowing shell, illuminated by a fading core, reminds us that even in death, the universe creates beauty. These nebulae are fleeting, yet their light carries the story of their stars across eternity. Supernova remnants, echoes of cosmic explosions. Some nebulae are born from destruction, the aftermath of a star's explosive death. These are supernova remnants, glowing scars in the fabric of space, where the universe's most violent events leave their mark. Let's explore these radiant echoes of cosmic cataclysms. A supernova occurs when a massive star, 8 to 20 times the sun's mass, exhausts its fuel and collapses, triggering an explosion that outshines an entire galaxy. The shockwave blasts gas and dust into space, forming a nebula that glows for thousands of years. The Crab Nebula, born from a supernova observed in 1054 CE, is a prime example, its tangled filaments glowing 6,500 light-years away. Supernova remnants are chaotic, their gases expanding at thousands of kilometers per second. Shockwaves heat the gas to millions of degrees, emitting X-rays and radio waves alongside visible light. The nebula's structure is a tangle of filaments, shells, and bubbles, sculpted by the explosion's energy and the surrounding interstellar medium. These nebulae are cosmic forges, enriching the universe with heavy elements, The supernova's core, crushed into a neutron star or black hole, leaves behind a legacy of carbon, oxygen, iron, and even gold scattered into space. These elements become the building blocks of new stars, planets, and perhaps life itself. The energy of a supernova remnant shapes its surroundings. Shockwaves compress nearby gas clouds, triggering new star formation in a cycle of destruction and creation. The Veil Nebula, a delicate web of gas spanning 110 light-years, shows how a supernova's energy can sculpt beauty from chaos. Supernova remnants also reveal the universe's physics. Their high-energy particles, accelerated by magnetic fields, emit synchrotron radiation, a glow that astronomers study to understand cosmic magnetic fields and particle acceleration. These nebulae are laboratories, offering clues to the forces that govern the cosmos. To gaze upon a supernova remnant is to witness the universe's raw power. These nebulae, born from stellar death, remind us that destruction is a precursor to creation. Their light carries the story of a star's sacrifice, echoing across the cosmos for millennia. The nebula is more than a place. It's a testament to the universe's endless cycle of creation. From the deaths of ancient stars come the births of new ones, each carrying the legacy of its predecessors. This is the heartbeat of the cosmos, a rhythm of light, life, and wonder that echoes across eternity. As we linger in this glowing nursery, we feel the universe's pulse, inviting us to explore further. If you enjoyed this journey, please consider subscribing, sharing this video, and checking our Patreon link below. Your support means a lot. We welcome your thoughts and suggestions in the comments. All visuals in this video were created using CGI technology. This channel belongs to all of us. Let's continue sharing knowledge together. I'm excited to learn from you as we embark on this adventure. If you found this captivating, I look forward to seeing you again soon. Thank you for joining me. Until next time.